Hi guys, this is another lesson for CCNA routing and switching, new version 200-301, and this is for implementing Ethernet virtual LANs or VLANs. We will start the implementing Ethernet VLANs. This is the part 1 and lesson 8 of CCNA course, and let me start about that. Well, imagine we have two separated switches in this video. Really, if we want to separate some networks from each other, for example, imagine you have you have the building, have some floors, and you want make switches, you want make networks in each floor, and all of floors networks separated from each other. In this case, you should put one switch per floor and connect their computers to that switch, like this one and this one. In the first switch, I have some computers connected to that, and the second switch same, not switches connected together, because we don't want when the computer in one switch produce and send broadcast packets to all of the network. We don't want that broadcast traffic affect to the other switches. So if want two networks or systems of two departments to be separated and no data is transferred between those networks, we must connect the computers to two separate switches. Well, but this is not available in each time, in each scenario. And more importantly, we are not going to separate the switches and networks from each other. If we were supposed to separate the networks from each other physically, and more importantly, we are not going to separate the networks. If we were supposed to separate the networks from each other physically, then why did we create them at all? So what's the solution? The solution named VLAN or called VLAN. Look at see about VLAN concepts. This is switch layer 2 of Cisco, for example, model number 2960. And so for achieve that purpose, we can have the switch like this, and we can create two VLANs. VLANs means virtual LANs. We can, I described in previous video, we can make some VLANs in the switch by command line and assign some ports in each VLAN by the command line as well. And with this operation, with this implementation, all of the ports that are in same VLAN, they can communicate with each other, and normally they cannot will communicate with other ports in other VLANs. In addition, I told you each switch has the default VLAN that's named is VLAN 1. The VLAN 1 is not deletable, is not be changeable its name, and it's not be change any other about its VLAN properties, and it is VLAN number 1, and by default all ports of the switch assigned to VLAN number 1 until you want to change the ports VLAN and assign them to another VLANs. Therefore, we can create VLAN divisions and partitions in the switch that are not related to each other, then make our desired ports that belong to certain computers members of those VLANs, and in this way, without the need for physical separation systems from each other, divide them in the network and isolate them from each other by these VLANs. Well, why should we use VLANs in switch? There is some reasons. First, To reduce CPU overhead on each device by reducing number of devices in each broadcast domain. When you have the domain, when you have the VLAN, or when you have the in more open view, when you have the network, there is some broadcast packets may be produced and transferred in the packet. And if in that network you have many computers, it is applicable to produce many and more broadcast packets. So for reducing number of devices that produce broadcast packets, we can create VLANs and divide computers in some VLANs for creating more smaller VLAN with more smaller computers and smaller broadcast packets. Second reason is to reduce security risks by reducing systems that receives data on flooding time. In some time, maybe some computer or some switches flooding the packet, for example, maybe for R packet, maybe switch produced for learning and getting requests and sending requests to computers to getting their MAC addresses and making MAC address table. I will describe more in next videos. To reduce this security risk that maybe happens by flooding some packets and in any time in any network situations, making VLANs will reduce that by limiting the network edge and putting each network in smaller parts we named VLAN. Number 3, to improve security by assigning different security policies per VLAN. When we want to put some computers in different VLANs, it means we can assign different policies for each part, for each VLAN, for each group of computers, rather than the other computers, and perform specific policies for each group of computers. The fourth reason is separate systems in different departments by VLANs. I told about that. When you have some, for example, building, maybe you have some departments, and if you divide your computers based on your department per your departments, it is very easy and easily manageable for defining each policy, controlling, defining any management implementation items by the VLAN, by the computer separated by VLANs. Number 5, make a smaller group of systems for troubleshooting quickly. Imagine you, for example, in a day, you start the work and you find that one computer cannot be connected to other computers. If you have one network with more and more, with many computers and many switches, it is very hard to troubleshoot and find the problem in this large amount of computers and switches. But when you have a smaller network, a smaller VLANs, you can easily find what's the problem, and you will start finding the problem, and you will start the troubleshooting by its VLAN, and step by step going ahead and find the problem. Number 6, reduce workload of STP. STP means spanning tree protocol, the protocol for avoiding the packet maybe it's in some situations packet put in the loop in networking, in switching. It has the special chapter in CCNA course. We will describe completely in next videos. But defining the STP and running the STP causes switches send traffic between them, and when you create VLAN, because STP is per VLAN, you will have the reduced workload for each VLAN for each STP protocol. The next item is communicating between VLANs through trunk port. What is the trunk port? Look at this image. This is SW1 switch 1 layer 2, and this is SW2 another switch layer 2. Some computers connected to ports of SW1 and some computers on SW2. And imagine maybe we have some VLANs on this switch and some VLANs in another. The trunk port is the port that defines trunking, and it is responsible to through and to bypass and transfer the packets from VLANs on one switch to the another VLAN, to the another switch VLANs. When you want transfer the packet from the, for example, from VLAN 1 on switch number 1 into VLAN 1 on switch number 2, the packet will be passed and will be transferred through the trunk port, so it can be received by the destination VLAN on the destination switch. In this image, we have two trunk ports, for example, VLAN 10, based on the previous image, like this. Well, VLAN 10, VLAN 20, for example, or VLAN 1, 2, not important. We have trunk port for VLAN 10, and we have trunk port for VLAN 20. VLAN 10 and VLAN 20. We created two VLANs on two switches. On the SW1, we have VLAN 10 and VLAN 20. We created two VLANs with some computer assigned to those VLANs. And SW2, we created also VLAN 10 and VLAN 20 and some computers assigned to those VLANs. When a computer from VLAN 10 on SW1 wants communicate and sending packet to another computer in the same VLAN, but on the other switch, the packet needs the trunk port. So by that trunk port identifies the VLANs that mark the packet and received by the destination switch and redirect to the related VLANs. Scenario 1, in this item we can have three scenarios. Scenario 1, communicate computers in same switch and same VLAN. For example, on SW1 we have VLAN 10 and we have three computers in VLAN 10, same switch, same VLAN. There is not any problem. All of computers that assigns or that assigned to the same VLAN on the same switch can communicate without any problem to each other. There is not anything. There is not need trunk port, not anything. Okay. Scenario 2, maybe we want to communicate computers in separated switch like this image, but in the same VLAN. The computer in VLAN 10 on switch 1 wants to communicate to the another computer on same VLAN but on the another switch. In this scenario, we need a trunk port that the VLANs allowed for passing that traffic on that trunk port need to be configured. Okay. For example, and another item is VLAN 20. VLAN 20 created on SW1 and SW2. In each switch, one computer assigned to that VLAN, one computer assigned to VLAN 20 on SW1, and another computer assigned to VLAN 20 on the second switch. So because these two computers are assigned to VLAN 20, we need another trunk port between this switch and we need configure to allow the through the traffic related to VLAN 20 from one switch to the another one. Now a question, do we need to allocate a separate physical trunk port for each VLAN created the same on the switches? It is not like that at all. This image, this picture, you see only conveys a concept, and therefore the existence of only one trunk port between two switches will be enough to pass the data traffic of all VLANs that created, and we only need to configure one trunk port, and we only and it's enough to configure that trunk port, and it will be passed through all traffic of all VLANs by that one physical trunk. Well, what's the scenario 3? Communicates computer in same switch but in separated VLANs. Maybe I have just one switch, two computers in VLAN 10 and two computers in VLAN 20. Just one switch. This scenario we'll consider completely in next video because it needs the router for make the communication between the separated between the various VLANs, but are on the same switch, and traffic should be passed through the router and come back to switch and going to the next VLAN. This is not for this video. Well, what's the VLAN tagging concept? In simple words, if I want to describe, it means tagging and making packets when leaving the trunk port of a switch so that the speed these tags, the destination switch can understand which VLAN the received packet belongs to. Look at this, VLAN 10 on two switches, created on two switches, and the trunk port is here. In physical concept, this is just one port. This is just one physical port. Well, the VLAN 20 is created on two switches, VLAN 20, VLAN 10. The computer created packets and wants to send packets through or from the VLAN 20 trunk port to the destination, and this is for VLAN 10. Well, and we again produce another packet for VLAN 10, and VLAN 10 wants to send packets, send it through the trunk port and received by destination, because each packet, in addition of the Ethernet label, it has the VLAN tag that defines this packet belongs to which VLAN on the destination switch. This tag shows this packet belongs to VLAN 10, so when received by the switch, it will be redirected into VLAN 10 and received by the destination computer, as same as VLAN 20, sent from the trunk port and received by the switch in the related VLANs. Okay, we're going to test and configure items. VLAN concept, configuring VLANs, assigning ports into VLANs, defining trunk port on switch, and checking VLAN connection. Well, this is Cisco packet tracer. Again, need layer 2 switch and another layer 2 switch. Well, some computers need for VLAN 10 and computers for VLAN 20. For example, let me set it, and for VLAN 10 and for VLAN, for example, 20. Let me draw the VLANs. This is VLAN. Well, again drawing for VLAN 10 and VLAN for VLAN 20. VLAN 20, VLAN 10, well, VLAN 10 computers, setting IP address 10.1.1.10.0.0, sorry, 2, and this computer 10.0.0.3, and VLAN 20, 20.0.0.2, and the last computer IP configuration is 20.0.0.3 with the subnet mask. OK, and connect computers to the switch, fast Ethernet into SW1, VLAN 10, for example, start from port 10 and 11, 10, and this is 10, connected to 10 ports, fast Ethernet 0/10, and these connected to 20 and connected to ports number fast Ethernet 0/20, and we need the trunk port between these switches. For example, fast Ethernet 01 connect to fast Ethernet 01. This is trunk port. Let me set label trunk port fast Ethernet 01. And this is okay. Well, let me create VLANs. On SW1, on SW1, and this is SW2. On SW1, I'm entering enable config terminal, going to global configure terminal mode, and I can use command VLAN 20 exit and VLAN 10, sorry, VLAN 20 exit. On this switch number 2, enable configure mode VLAN 10 and VLAN 20. Well, now I should assign related ports. Port number 10 for VLAN 10, port number 20, 0/20 for VLAN 20. I'm going to interface related interface port number 10, interface fast Ethernet, interface fast Ethernet 0/10. If you want assign the port into a VLAN, you need make its port as access port. Switch port mode access, switch port access VLAN 10. Well, exit. I'm going to interface fast Ethernet 0/20, switch port mode access, switch port access VLAN 20. Well, in another switch, we need perform same implementation. Interface fast 0/10, switch port mode access, switch port access VLAN 10. Look at interface changed its LED. And exit. Interface fast Ethernet 0/20, switch port mode access, and switch port access VLAN 20. This is same operation occurred. Well, And the VLANs created in this switch, VLAN 10, VLAN 20, these computers are VLAN 10. But we need, for final implementation, we need configure the trunk port. This is the fast Ethernet 0/1 on both switches. Exit, interface, fast Ethernet 0/1, switch port, mode, trunk. With this command, you can set the desired port or related port or specific port into trunk mode. Line protocol up and interface is up, and its line protocol also change the state to up. But this is change the state to down. Why? Because the another side is not configured for trunk port. So we need to configure this port as well, this switch as well. Interface fast Ethernet 0/1, switch port mode trunk. Well, let me check VLANs, show interface, show VLAN brief. For the first time, we have VLAN 10, one port, and VLAN 20 contains another port in that. And show interface brief, show interface status, interface number 10 is assigned to VLAN 10 and number 20 assigned to VLAN 20. Well, okay, another command need on trunk port which change the state in this interface into trunk. For example, if I see show interfaces trunk, it will show us the trunk port. This is show us that fast Ethernet 0/1 is on trunk port and encapsulation is 802.1q. Trunking mechanism has two protocol, ISL and 802.1q. I will describe in the next video. And status trunking and native VLAN I will describe later. Okay, no problem. And in the other switch, implement same command, show interfaces trunk, and the trunk, the fast Ethernet 0/1 is trunk. Well, another command is need to configure on trunk port is which VLANs are allowed for pass their traffic through this trunk port. And interface, I'm going to in interface trunk port, which is fast Ethernet 0/1, switch port mode trunk. I did use that, and switch port trunk allowed VLAN 10, 20. It means the switch will allow us to bypass and sending traffic related to VLANs 10 and 20 through this trunk port. Again, this command in another side. Configure terminal, interface fast Ethernet 0/1, switch port trunk allowed VLAN 10, 20. Check it, shutdown and no shutdown, no shutdown. Change the state to up and change the state to line protocol is changed to up. If you remember, above it was up and down in this switch. In this switch, change the state. There, down. Line interface is up, but line protocol was down. Well, shutdown and no shutdown. No shutdown, interface up, line protocol up. Okay, that's all, and it is finished. Now each computer in the same VLANs on the separated switch should be able to communicate with each other. For example, 10.0.0.2 should be able to ping 10.0.0.3, and as well as 20 VLAN 20 or 20.0.0.2 with 20.0.0.3. Let me, this is up. Okay, check this one, ping 10.0.0.3. This is 10.0.0.2 ping, sorry. That's successful and succeeded, and this is 20.0.0.2, and I ping 20.0.0.3. Completely done. All computers in the same VLAN but in the separated switch can communicate to each other by the trunk port configuration between these two switches. This is all configuration for making trunk port for this scenario. The another scenario is maybe you have one switch, for example, like this one. You have one switch and some computers in different VLANs, for example, one VLAN and another VLAN. This is VLAN 10, for example, this is VLAN 20, but you have just one switch. In this scenario, you will need router. You will need a router, for example. You will need a router that if one computer wants to communicate to another computer, it needs to go and send packet to the switch, and from the switch needs to send to router and come back to the switch, and from the switch goes to the another VLAN. We will describe it into the next videos. Well, and have a nice time. See you in the next video. Bye.